Okay, and right now I would like to introduce Georgia Weidman. She's going to talk about leveraging mobile devices on pen tests. And if you have any questions, please raise your hand and I'll bring you the microphone. Thank you.
All right, hi everybody. So some of you may have heard last night kind of sucked for me, so I feel like I have two choices. Either I come up here and suck, or I come up here and be really awesome. So I'm gonna go for the second one, so hopefully I can pull it off. But, you know, I've got my coffee cup just in case. And if you don't know what I'm talking about, probably better for you. Anyway, so this sounds really loud. Is it as loud for you guys as it is for me? Okay. Because it's basically like echoing back at me. But we're going to talk about leveraging mobile devices on pen tests. So if you've sat in any of my other talks in the past, I've done a lot of mobile nonsense, and this is kind of my next thing in mobile nonsense. If you can exploit a device, which we have talked about that ad nauseum, if we can in fact exploit a mobile device, what does that get us in terms of the enterprise? What can that mobile device get us that, say, perhaps exploiting someone's laptop would not? So that was my little talk here. So unfortunately, when I go on pen tests, I see mobile devices joining the network like this. This is kind of unfortunate, but this is, you know, how things work. Somebody sets up a wireless access point, everybody starts attaching to it. They say, oh, I'd like to bring my iPhone today. Well, I know the wireless password, cha-ching, we're in. And we're just another node on the network, so we're there with workstations and laptops and possibly even servers. So depending on the setup, we may be able to see all sorts of nonsense, and that perhaps is not so grand. I'm not sure, we'll see. Because we might be able to do something like this. So I'm on the nasty mobile device, and I have taken it over. They went to the coffee shop and joined that open Wi-Fi network and downloaded something from me, and now they're in trouble. And they go to work the next day and get on that wireless access point, and then suddenly I have access on the local network to those other devices. Yay! Anybody here do pen testing? Anybody? So, external networks, internet facing. Sometimes bad, sometimes really good. I get a lot of them, at least in my pen test career, where, oh, we've got one port open, or even better, we have no ports open. We have very little risk if we're looking at this device here. So they're actually kind of doing a good job sometimes, which, you know, in security, we never expect anyone's ever going to do a good job, but perhaps sometimes they do. What about internal networks? Are internal networks ever completely free of vulnerabilities? Yes, no, maybe? No, I would say absolutely not. I at least have never run into an internal network where I was not able to get at least some sort of domain admin access to at least one domain. So, you know, there's missing patches, default passwords. Somebody says, oh, I want to build a web app today, but I don't want to install Apache or MySQL or anything, so I'll just install XAMPP and leave PHPMyAdmin wide open to everyone. Yay! These things happen. We, unfortunately, have not figured out a way to fix this. I just want to make it a little bit worse by bringing mobile devices into the picture, as if we're not doomy and gloomy enough. So this is probably how it should be done. You know, we do some sort of isolated virtual LAN over here, where here our mobile devices are, and only our mobile devices, and perhaps they can start attacking each other. iPhone A can attack iPhone B, but they certainly can't attack our production server over here that we really would rather them not be attacking, or our company workstations. We do not like that. So if we would just isolate them, that would really fix a lot of our problems. But has anybody here ever seen a network where mobile devices were isolated from the rest of the network and yet bring your own device existed? A couple people. Those are good clients. Yay for those clients. Most clients, they're more like this, unfortunately, because, you know, everybody wants to bring their own devices and nobody wants to deal with the infrastructure necessarily to do it correctly. The thing is, bring your own device is this big buzzword, and every time I say it, or BYOD, I feel like somebody should be throwing a tomato, or at least a shmoo ball, at my head. But bring your own device is not new. Company laptops, access points, and my personal favorite, game console. I love the game console. You know, have one in the break room, and then who knows what's on there. I know there was a talk at DEF CON a couple of years ago about putting malware on the game stations, and then they started attacking other things on the network. So I don't know why we're so excited about this bring your own device bit. It's obviously been around for a while, so I don't know. But mobile devices do add one little interesting feature, that being the mobile modem. So we have attached to access point, get Wi-Fi. Like for instance, I'm here in Poland and my phone is American. So if I turn on data without on the Wi-Fi, I will get a very large phone bill. I don't like that. So I use Wi-Fi whenever I can. I join random Wi-Fi access points as I walk down the street. It's very insecure, but functionality before security. So we also have this mobile modem. So we in our corporate network, we can control our access point, we can control our network, we can packet sniff things going in and out, we can do all sorts of filtering, we can do pretty much whatever we like within the bounds of the technology that we have. But when it comes to that access point over here, the network that you're on with your carrier, that's really up to the carrier. So unless you do bring your own device where you have your own carrier and hand out smartphones, but that's not really bring your own device, is it? So pretty much in any bring your own device policy where there is going to be devices with mobile modems, so iPads, all the phones, some of the other tablets, this is kind of scary because we don't know what's going out through here. We can't watch it all go through. And we've been seeing for years it's even possible that that network that it's connected to may not even be the legitimate carrier network. It could be, Kristen Pageant's network that we saw a couple of years ago. And I think there's a talk here about CDMA femtocells, or at least it's at some conference I'm going to soon. It's hard to keep up with it. So that's kind of scary because this phone's probably talking to other devices in our network. It's talking to corporate data. It's got my emails on it. It's got my reports on it. I'm sure my customers would love to hear that. And I don't really know where it's going. It's going off somewhere in the ether, and I don't know. And I find that my customers really don't like it when I say I don't know, but sometimes I just don't know. So naturally, I was like, all right, well, what do we do when we have devices that might be vulnerable? Well, we run Nessus against them, of course. That's what my CISSP taught me. So I did. I ran Nessus against it, and it didn't find anything. So this is my iPhone that's made vulnerable on purpose for one of my classes. So this iPhone that has no vulnerabilities, it is jailbroken. It has SSH installed. It has the default password, and it doesn't have any MDM restrictions on it. So it's basically as bad as it could possibly be. Plus, it's a really old version. It's like 4.3, because I use it to teach jailbreaking in class. So this is a really badly secured iPhone. But according to Nessus, it's really awesome and should definitely be on our network gold star. Oops. So, the problem. Smartphones in the network. I've got some servers over here that have our private data and our things that we really don't want our competitors finding out about. Or how about our client databases with credit card numbers, social security numbers, other things that we really don't want dropped on the internet? What about password databases? We like it when password databases end up on pastebin, right? That is win. No, that's not win. So this is a problem because every piece of data that phone potentially can get to, either because it's allowed to, either it can interface with these servers like email servers. We can download our work email on our phones, so we can go to conferences like this and still answer our emails as though we were never gone, so we don't have to take days off, which is awesome. But every piece of data, whether we're allowed to or not, or if we can break into the server through the phone and steal data, can be going out through the mobile modem. So at least my clients, a lot of them have like no egress filtering stuff whatsoever. Basically, if you can call out, you can call out. Some of them are doing a bit better. You gotta do like port 80 or 443. Some of them actually even do stateful inspection, and we have to use like Meterpreter, HTTP, or HTTPS. And I even had one client once who did so much egress filtering that you actually had to be inside the Internet Explorer process validated as a domain user, Otherwise, you weren't getting out, period. So, they could surf to the internet and do all sorts of things there in Internet Explorer, but they couldn't use like AIM or Skype or anything else unless it was a browser extension, which was really awesome. Gold star for that. So they're probably the only people I've ever seen that if we break into an internal box, I can't get data back out. And, that's important. So let's just pretend that everybody won't let data out, and maybe the phone can fix this problem with this right here. If I can't get data out of the internal network via the network, what if I have a second network that has no restrictions? Let's not pull this off with my gestures. That would be rather unfortunate. So let's talk a little bit about the threats against these devices, because before we're actually on the device and saying, oh, I'm on your device, now I'm going to destroy your network, it would probably be good to start with ways we could actually get on the device. Is this actually going to work? And everybody's favorite, applications or our apps. So I used to think users, they don't download random apps off the internet that do nothing. Apps have to be useful and at least have a nice graphic going on. But no, I actually saw some research for some other smartphone researchers where they were trying to see if they could get malicious stuff past Android Bouncer, and they would put things like, please don't download this is really stupid, this is a test, and they would still get downloads. So potentially some of that is bots that just go out and download everything, perhaps malware researchers themselves, so kind of goes full circle there. But on the other hand, it seems like people actually do download apps, and malicious apps do happen. They don't seem to happen nearly as interestingly as I, as a smartphone researcher, would hope. It seems like the people writing these nasty apps in the wild seem to be about 2 years behind the people talking about it here at these conferences. But our apps on multiple devices, everybody rags on Android that they have this really awful application model. And I suppose that's true. The permission model is completely broken. Users will just click yes on everything, and suddenly you can join the phone to a botnet, steal their data, whatnot. You don't even have to run an exploit. You could run an exploit too. You could ask for no permissions, run a root exploit against an older version of the firmware, and once again, do malicious stuff through an app. But iPhone has also been known to have issues, not just through jailbreaking, but also through applications. Charlie Miller's Instastock is an example. They just put so much belief that no malware will ever get into the store. They actually have less oversight going on about what apps can do once. Once you're in the store, you're like, yay. And, Charlie Miller's awesome, but, he's probably not the only person on the entire planet who can do something like that. So malicious apps will happen on whatever platform you deploy. So the question is, will your employees download them? So if your users are not downloading any apps whatsoever on any of their devices, this does not apply to you. But if you have just one user who will download a malicious application when prompted, then you might have a problem, because it only takes one. So I guess this slide is kind of dated. Does anybody even play Angry Birds anymore? But if they do, anybody Angry Birds? I didn't think so. That was kind of a year ago at least. But whatever's cool now, download some add-on for it, and it steals your data, or it joins you to an SMS-based botnet. Awesome, not awesome. And it walks into our little enterprise and destroys things. Unawesome. Other problems, software bugs. Anybody here ever written any buggy software? 2 hands for me. I've written some very buggy software, and so has everybody else that I know. So I guess you guys don't write software at all, or you're not being, completely honest with me, because I write buggy software. A lot of the smartest people in the world who are writing these pieces of software for iPhone and Android and, Microsoft and any other platform, the Linux kernel has a tendency to have vulnerabilities. Web applications, they have some vulnerabilities too. Why should our smartphones be any different? Why is anyone surprised that iPhone is jailbreakable? I'm not sure. I'm not surprised. You can get root on anything else. You can get root on your television. You can get root on your car. So of course you can get it on your smartphone as well. So the browsers have bugs. So we've got our client-side attacks. We see that the same way we see it in our traditional PC platforms. Somebody browses to something And near-field communication makes it even more interesting, because if you can make somebody like Android beam with you, then it'll automatically open whatever you just sent them. So open up in the browser or a PDF reader. And then if there's a vulnerability there, then pop goes the Android, which is, again, unfortunate. But these things have bugs. That actually happened to win Pwn to Own last year with the Android, that they actually used near-field communication to people from NWR Labs. And of course, the kernels have bugs. I actually think Android is really interesting that it once had one of the exact same bugs that had previously been patched in the mainline Linux kernel was still sitting in the Android kernel. So the udev exploit that you may have heard of from Linux or from Android, where udev wasn't checking if whoever was asking you to load kernel drivers actually had permission to do so, which these are oversights that people make. Security is hard. So we have to assume that our browsers, apps, because again, apps, anybody can write apps. You don't have to go to secure coding school to write an app. You don't have to get a certificate that says, I know how to write secure code. And even if you do know how to write secure Java code, have you ever heard of an intent or a broadcast receiver? These are new things. You need to go back to secure coding school. And going back to school is hard, so nobody does that. So all this stuff is going to be buggy and disastrous, and God only knows. And what about our Androids again? Anybody have an Android that has the latest and greatest firmware? Like, what are we at, 4.2, 4.3 now? Anybody got one of those anywhere? A couple people? All right, well, I don't. I have 3 Android phones, and none of them have the latest and greatest firmware. I'm pretty close. I've got an ice cream sandwich, but I have another one. No, good story, right? Okay, so I dropped one of my Android phones, my only Android phone at the time, into the jacuzzi, and I needed an Android phone to demo at DEF CON, so I naturally needed to get a new Android phone. I was waiting for the Galaxy S3 to come out, so I didn't want to buy a big new phone, start a new plan and all that, because I just wanted to get the S3. So, I go to my local electronics store, and I say, I would like an Android phone, please. And they got me a nice prepaid Android phone off the shelf, and it said on the box, secure Android device. And I was so excited, because I'd never seen a secure Android device. Never. So I was going to buy like 100 of them. But I started with one. I took it home, opened it up. I was so excited. First thing I do, I go to the system menu and I say, okay, what version of the Android software do you have? 2.3.1? Real secure Android device. That's false advertising. So I go system update, your device is completely up to date. Who does this? Really, this is so broken. But unfortunately, that's just what you're going to have to deal with. Sometimes you're going to get users who don't want to update on the iPhone side because they want to keep their jailbreak, which we'll talk about a little bit later. But on the Android side, you've got people who have a phone that's possibly brand new, maybe just a few months old, certainly not the requisite 2 years in the United States to get a new phone on your plan, so we can assume our users are going to want to use them for at least a year and a half, perhaps 2 years. And if we say, no, you can't bring your Android device because it doesn't have ice cream sandwich, that's going to make some people mad. They might show up at your office with pitchforks and try and murder you, which as a security person in the enterprise is generally to be avoided. So, another one, social engineering. So I used to believe that social engineering didn't really exist. Well, I knew it did. But like those phishing emails, right? Who makes this stuff up? Users don't click on links in emails. That's ridiculous. But then I started doing some engagements that including phishing emails, and I wasn't really good at it either. I would make little fake Gmail addresses, and I would clone their websites, and I would say, oh, we're starting a new company portal, and if you log into it, you get a chance to win like $100 and a gift card for Amazon. And this was really dumb. I've seen stuff that's way more advanced than this. But the sad thing was, people were still clicking on it. People were still giving me their credentials. So in fact, I was wrong about all of this. Social engineering and phishing actually does exist. But let's pretend like it doesn't. let's pretend you've done a really good job of security awareness training in your enterprise, and no one, I mean no one, is ever going to click on one of those silly emails, no matter how sophisticated it is. They are going to check everything to make sure it is legitimate, and you will get a 100% awesome rate on your phishing tests. I've never ran into anybody like that personally, but let's say they exist. What if it's a text message? Are they going to click on it then? I will tell you that I once clicked on one. It was really early in the morning, and it was a lot of money. And yeah, I've always had this idea that if I could find the one Nigerian prince who really does want to give me all his money, I'll be set. So I guess I have a special relationship with phishing, but all you need is one. It'll totally make up for all the money the other people stole. If you really could get like $100 million just by giving somebody your account information. But alas. So, text messages. Are they going to click on the links? Probably. Have you guys seen any of this over here? At least in the United States, we get a lot of them coming through. I may get more than most because I publish my phone numbers online in my talks, but at the very least, I get a lot of stuff that says, you've won something, please click this link, or sign up for this and you'll win a free burrito or something. And, I am sometimes very hungry and would like a free burrito, but I have to stop myself and say, no, this is a social engineering attack. But I am a security professional. You can't assume that everyone's going to be quite as smart as me. So, will they click on the links? Probably. Will they even download malicious apps? No, this is funny. One of my carriers for my phone, so I have different ones, but one of them, and I won't name names, sent me a text message one day, and it said, you are a premium handset subscriber. You can download this awesome new security app. Whether the security app was very awesome or not is another story for another day. Short story is no, it was really lame. But what this link actually did when you clicked on it is it didn't take you to Google Play, or I guess it was, the Android store at the time. It took me to a third-party website that claimed to be, carrier.com, but, you can change that around a little bit, get a domain that's similar. So actually, the official carrier was teaching users, please download apps from text messages that you can't verify they're really from us. It said it was from number like 1111. At least on the iPhone, it's actually really easy to spoof that. You can do that with just by user data header stuff. So you can actually do that with my tool. So I can make that attack, and I can make it such that all you have to do is click a button to run that attack. So really, our carriers should not be teaching people these things. But they don't listen to me. They still do this. Nobody listens to me, except you guys, apparently. All right, so the last one, everybody's favorite on the iPhone side, jailbreaking. See, jailbreaking is this weird phenomenon, because probably the jailbreakers are more famous than anybody in InfoSec. Have you seen the Twitter followers of these people? We're looking at hundreds of thousands of people. And I thought I was cool with my measly, 4,000 followers. Like, oh, I'm a rock star now. But no, I need an iPhone jailbreak. You can go sit outside the supermarket and run a poll. Why do you jailbreak your iPhone? And you get a lot of people, yeah, we totally jailbreak our iPhones so we can run the apps that we want and stuff. You get a lot of people who probably don't really have any reason to be jailbreaking it, who are in fact jailbreaking it. So, are users jailbreaking their devices and bringing them into your enterprise? Probably. Can we stop them? Well, I know a lot of MDM vendors that seem to think they can, but I've never seen any of them be particularly successful. The trouble with jailbreaking is quite simple. What you're doing when you jailbreak your device is going out to the internet and Googling, iOS 5 point whatever, jailbreak, and whatever comes up in Google, your average user are going to click on one of the first two, right? And they're going to download that to their computer, plug in their iPhone, and magically Cydia will show up, or it will not, and they will become enraged. But as long as Cydia shows up, happy, we can download stuff now, okay? But you're expressly giving a program permission to exploit your device. You don't know who wrote that jailbreak. You don't know what else it's doing. So as long as you get Cydia, you're happy, but they have root privileges. So my guess is if they can write a jailbreak, they can probably join your phone to a botnet as well. So what else is that jailbreaking program doing? I don't know. Probably nobody else does either. and it's walking into your network. Yay, not. All right, post-exploitation. So now I've gotten onto your device in myriad disgusting ways, like social engineering or sending you a nasty app that looks like a nice app, or just logging into your jailbroken iPhone through SSH with the default password Alpine, because unfortunately that still happens. Ouch. So I can either get like a command shell on the device, which kind of like having a command shell on a Linux system, except some of your binaries are missing. We could also do like app-based stuff, which I think is really interesting. I do a lot of stuff with like backdoored apps that has additional functionality in the background, because as we'll see when we do the demos, like any application on the Android, it doesn't have to have permission to write stuff to the file system. It does have to have like SD card permissions, but they can all write to internal storage, so they can download stuff and run it, which is awesome that any app can do that. So there's a lot of stuff you can just do as like backdoor functionality that you don't even have to ask for permission for. So I think that's really interesting. So I think actually like working through an application rather than working straight at the command line can actually be really interesting. So we'll look at a bit of that when we do the demos. So the natural question. So I do a lot of pen testing. A lot of us probably do. It pays the bills really well. So we go do some pen tests. My client Googles me and says, George, you're a smartphone hacker. What can you tell me about the smartphones in my environment? Well, nothing. Not really. None of my pen testing tools really cover that. There's 3 modules of Metasploit for iOS, and one of them's default password, and the other 2 are for iOS 1. So yeah, that's not going to get me very far. We already saw what Nessus has to say about a badly configured iPhone. So my answer to my client is really, I don't know. And then they're like, well, what if I paid one of your competitors? Would they be able to tell me? And I'm like, no, probably not. And so they're like, so you're basically telling me that when we're doing our pen tests, we're completely leaving out mobile devices? I'm like, yeah, pretty much. And I'm like, well, at least you're in good company. I know like the US military has a bunch of Androids on their network. .mil has Androids and iPhones. I mean, this is not anything that's super secret because they told me and I don't have a clearance. So I guess we're all in good company and we're equally vulnerable to nastiness, which I guess is good. But it's also kind of bad because we want to assess our risk. So how do we assess this risk? Well, naturally, we test for it. We know how to do this. So we can test for remote vulnerabilities. Hopefully, we're not seeing too many remote vulnerabilities, but we may see a few, the SSH password thing. You see a lot of stuff that comes up as saying it's remote, but it's really client-side. Like when you open stuff in the browsers on Android and it had that telephone tag, the USSD stuff, and it would wipe your phone or do anything else that you told it to do. Yeah, automatically dialing numbers, never a good idea. Check Samsung. So that wasn't really a remote attack, it was a client-side attack. But the news said it was remote, so we could put it in the remote category if we wanted, I guess. Of course, also our client side, so opening stuff in browsers, opening stuff in other apps, viewers, readers, things, anything that'll open some sort of document that we give it that could potentially be nasty. But this isn't new to us. We've done this on the PCs forever. Acrobat Reader, Winamp, all the browsers, Java. Java's always a fun one. Actually, in the case of a Java ODE, probably the only safe way to browse the internet, short of turning off Java, is to do it on a smartphone, because they don't actually use the Java VM, which from Android seems kind of silly since they're basically based on Java, but yet they don't use the Java VM, so safety. We can also do social engineering, and once we're on the device, always nice to see about local vulnerabilities as well. So that's kind of from my old talk, and this is my question for today. Once I get on your device, what else can I see in your enterprise? If I'm doing our external pen test and I can hit one of those devices and I can make it walk into the internal network, which it probably will when somebody goes to work, or even they VPN in from home, using the mobile devices as the VPN tokens was really the worst idea anybody ever had, in my opinion. But as soon as it jumps into the internal network in some way, what can I now see? What can I now attack that all of your firewalls suddenly aren't protecting anymore? Oops. So that brings us back to this. So this is my goal. I want to do some nasty with your phones, and I want to attack other devices. So if I can attack another device, I could just, in most networks, as we talked about before, I could send the traffic back out. Who does really good egress filtering? Not very many clients that I've dealt with, but on the rare occasion that they do, if I cannot get out through normal network communication means, I am just blocked. They have really good stuff going on in terms of filtering. I can actually use the exploited device. So as we'll actually see in the last demo today, I'm going to hit the internal network, have it attach back to the phone. So it's basically going to throw its reverse shell. Instead of out to my EC2 instance, it's going to throw it to the phone. So it's not leaving the network. And then the phone via SMS. So even if that phone's on the network, completely out of band, is going to send that shell back up to my server. So it's going to bypass every firewall rule you've got. And that is awful for everybody's security. So let's do some demos. I like demos. So I'm going to do some live demos, and that means I need to plug in my access point. So I once tried to do this on like Black Hat Europe's network, and for some reason, like my tool actually does everything that's network based in HTTP for just that reason, so it can get through pretty much anything. It's just real HTTP requests, and even like internally on the network, it wouldn't let me do it. So that was really unfortunate. So now I always use my own access point because that's just a waste of time if I don't. So now we got an access point. Awesome. All right, so let's do some nasty to the internal network. All right, so where's my access point? It's open and it's called Linksys. I use it for class to show vulnerabilities, but you can come on here and start attacking my stuff if you want. I usually end up with at least one nastified device for every time I show this stuff. So we're going to use emulators for this, and for the last one with the SMS, I'm actually just going to show you a video because you can't really do it with emulators because they really only emulate the SMS stack. So we're going to use a little tool called the Smartphone Pentest Framework. So this is Kali Linux here. Let me clear the screen and make it bigger. So SPF, the Smartphone Pentest Framework, was on Backtrack 5 R3. It was one of those tools like Armitage, so at least I'm in good company, that got dropped out of Kali, but you can just do a GitHub clone, and then you have it, and it has a nice install script for Kali, so we can use this guy. It is currently written in Perl, so you can all throw your tomatoes now. I will hide. All right, no tomatoes. But somebody's working on porting it to Python like as we speak, so it'll be in Python really, really soon. So anybody who wants to do work on this but hates Perl, you will finally be happy. I've finally listened after almost a year, and I'm fixing it. All right, so very much like I think the Social Engineer Toolkit, so a lot of menu-based stuff. It's been asked that I put in stuff where you can do like your Metasploity use this module things and not have to click menus. So that's coming in as well. First thing I want to do actually is clear my database. Actually, first thing I want to do is make it so you can actually see the whole VM. So number 7, destroy the database. Yes, all right. So we're not actually going to look at attacking the phones in this example. I'm just going to drop an agent onto the phone, and we're going to do all the nasty with the post-exploitation. If you want to see like ways you can use SPF to attack phones, there's lots of videos of my old talks. My one from DerbyCon last year I think was particularly good. At least my footwear was better than today where I'm actually not wearing any. All right, so I want to attach framework to a deployed agent, and I can actually generate an agent app. So number 2, it's basically going to backdoor any application that you have. It comes with just a blank front end that has no front end, and one of Google's demos. You can bring in any source code that you want. I'm working on making it so you can do any application that's already pre-built. That isn't particularly hard. You just decompile it back to the Smiley code and then backdoor or add your Smiley code, and then in your application manifest, just start the backdoor as well. So it's not particularly hard to do it on a pre-compiled app either. But for right now, it just does source code, and it will backdoor any application that you have. Let's do maps demo. Phone number of the control modem, so one of my emulators. Control key for the agent. I always use key 1, that's terrible crypto. Where do I want it to check in on my web server? Android Agent 1 is always what I use. Helps me remember. And then it just uses the Android SDK. So no Eclipse required. It just builds it for you. Yay, everybody likes automation, particularly on their pen tests. All right, so it built that for me. So what I think is probably the coolest thing about SPF is it allows you to do mobile-based attacks. Oh, we're already still attached. But it allows you to use the devices you already have. I really hate tools that make you like sign up for a premium SMS service. That makes me really unhappy. Let me actually make sure my IP address is not changed. Oh, it did. It changed. That's unfortunate. So I actually need to change my config file. NAO-config. IP address to 102. How much time do I have left? Okay, I can do that. All right, so then I need to rebuild that app because it's going to call home to that IP address. So I will just regenerate the Android app very quickly. 5554, Kiki1, and Android Agent 1, and build. And then here, this is the pen tester controlled device, so I just built a little app that allows you to hook up to SPF. So this will hook you up to my SPF server, and it'll allow SPF to use your mobile modem for attacks just in the background until you tell it can't anymore. So it basically allows SPF to backdoor your device. But you know, it will run on anything Android 1.6 and later. The near-field communication stuff obviously needs later versions and a near-field communication-enabled device. But we can pretty much use any burner device we can come up with. So I want to attach to a mobile modem, so I can create the app. I can install it via ADB, but we already have it here. So I'm just going to attach to a smartphone-based app. I can also do, like, plug in my mobile modem through the USB, and it'll use the serial port to send commands to it. So you can also do that. But let's do the app, and phone number, and control key, and where do I want it to check in? This says app. So as long as these values are the same, it basically does a three-way handshake with each other. And then now we can use this guy in the background, and we can use that mobile modem to do nasty stuff. So let's send our other emulator that application I just made. So run a social engineering or client-side attack. I'll just do the easy one here, direct download the agent. You see some other attacks in there. So all I'm going to do is send them a text message saying, please download this. Tell them it's an Android. Where do I want to host it? Confident. And what's it called? con.apk, anything I want to call it. And delivery method, SMS or near-field communication. These emulators don't have near-field communication, but it will allow you to Android beam stuff to devices. And who do I want to send this to? My other emulator. And do I want to use custom text or just the basic? So I'll just use the basic. And then it'll send that text message over to me. Here it is already. You can change how often it checks in, because obviously the more it checks in, the more it'll run down the battery. But I often forget to turn mine off, and I don't really notice a difference. So you can change how fast it goes. But all right, so it's like, this is a cool app. Please download it, because, yeah, no one would ever fall for that. Unfortunately, they would. So I play the user, and I download this app. So this is one of our client's devices, whereas this one over here is ours, the Pentesters. So I'm going to install this application. And this one actually does ask for additional permissions, but I'm working on ones that don't. I just want to give you more options based on like what you want to do. If you want to use specific permissions, it asks for them. If you don't, then you don't. So I open it up, and it looks just like the Google demo. So your app looks exactly the same. It just starts some nasty in the background. Everybody's favorite thing. So now I want to attach to it. So I attach to the deployed agent. Tell them where it checks in. And this is the only thing that takes time, because since we don't actually control this device, I can't really tell where it is in its clock cycle. So unlike the other one where I could just three-way handshake and it's done, then this one I cannot so much. I think I'm about to get some, like, it's 10 minutes time coming my way. I can see it coming. 8 minutes, all right. So while that's running, I'll just show you my other two slides. Where's my slideshow? And so I want to thank the DARPA Cyber Fast Track program for paying for the original version of SPF. That was really awesome of them. It allowed me to quit my job, which I kind of hated as a junior pen tester, even though I generally thought I was smarter than most of the senior pen testers who really couldn't do anything except run Nessus. So now I'm the CEO and get to come to places like this. So heart to DARPA. And that's my contact information, but let's go back to the demos because they're more interesting. All right, so it attached, so now I can send commands to the agent. So there's the agent that I just attached to. So what I want to do, I can also, I have another demo that we're obviously not going to get to, where we just drop the in-map binary for Android onto the device and then run it, because again, you can drop any binary you want, so as long as it knows how to run on Android, and then we can just chmod 777 on it, and run, yay. And we didn't have to ask for any permissions to do that, but we don't have time for that, so I'm just going to get straight to the evil stuff. And so here's a VM I use in class, nice old Windows XP VM, and here we have war FTP, which is apparently currently dead. Where's the nasty file? There it is. Apparently no, that's not it. Here it is. Every time this thing crashes, it writes nasty to the database. There we go. There. All right, so if you've ever done any exploit development, you've probably seen this. I just use it as the example because I have to write the code in C because Android understands compiled C. It doesn't natively understand Python or Perl or anything I might rather use. So I wanted something that was easy to write C code in since I don't like C code. So what is this guy's IP address? 103. So 5 minutes. All right, so I will run this demo. And so I need MSF Venom. And I'm just going to generate this Windows Meterpreter payload with the new IP address in it. And lhost equals 192.168.20.102. So the IP address to call back to here. And then the bad characters for this guy are null, carriage return and line feed, and also our @ symbol, since this is FTP login, and I want its format in C. So it's going to generate that for me. So this is just Metasploit. I'm not doing anything special here. All I have to do that's special is compile this code for Android, which luckily SPF will allow us to do. So, come on. Metasploit, you're so slow. It's not like we're in a rush here or anything. Invalid payload. Did I... What did I do wrong? Oh, the starting slash, duh. I start to make mistakes when I get nervous. All right, so you're going to generate this time, so we can actually have a real demo here. I should talk less and demo more. That would be more exciting. There we go. Shell code. Everybody likes shell code. So I just grabbed this shell code, and I'm going to replace the shell code that's already in there. This is for a different IP address. So this is on desktop and nano war FTP interpreter. .c. Yeah, I'm not that cool. So then I'm going to get rid of this and replace it, and we're going to again waste time. The most time-wasting demo ever. If my IPs hadn't changed, this wouldn't have been a problem. Or I could just set static IPs like a normal person, but that would require some skills. And, I am just a pretender. I don't really know anything about phones. I'm just making it all up. No, seriously, I'm going to give a talk one day that's like that article about InMap where they just made everything up. I'm going to give a talk that's complete nonsense and see if anybody notices. My guess is they probably won't. I'm not funny, I know. All right, are you done now? I should have just used VI and fixed this problem. All right. So I copy that in. Yay. Start up Meterpreter. or my handler here. So again, this is just Metasploit, so I just have MSF console, so it's listening on port 4444, which is the default. So what I want to do is actually compile code to run on mobile devices. So I want to compile some C code for ARM Android, and it's desktop war ftp meterpreter.c. And what do I want to call it? War ftp meterpreter works for me. So then it says no input files. Oh, wow, I really am screwing up. All right, I can fix this by actually giving the path correctly. Root desktop war ftp meterpreter.c, and I want to call it root desktop war ftp meterpreter. And then it builds, and it has some warnings because I'm not a very good coder, but then I want to actually download it onto my agent. So number 6 of things I can do, download a file, and this does not require any permissions. So any app can do this, war ftp meterpreter. So I'm going to have it download that. Where do I want to put it on my web server? Con works for me, and it's called war ftp meterpreter, and this will actually dump it onto the device. I can deliver it via HTTP or SMS, and so the next time the agent checks in, it will download this executable onto my device. So I can actually see it come in over here. Android.google.apis, CD files. So I'm just, and see, it just dropped it. So this is just ADB shell. So now I can actually run it. So execute a command. Again, no requirement for any permission to execute a command. So the command I want to run is war ftp meterpreter that I just dropped on there, that binary. And I need to tell it who to attack. This is just C code I wrote. So it's 103 on port 21. So I'm just running any command I want. Like if I had more time and had talked less, I would have showed you nmap as well and nmap the network. And so I'm just going to run this, and it asks me, was it downloaded? So if it's in our files directory or if it's a system binary. So I say, yes, it was downloaded, delivered over HTTP, and I'm out of time, so this guy had better come in really fast. So it's going to run this, and then you'll see a meterpreter come in. And are there any questions now that they're going to kick me off the stage? See, there it comes. Yay, meterpreter. Woo! All right, so this is just the example with HTTP. There is a video online with the SMS one, so I was going to show you that, but I ran out of time. So thank you all for listening to me for 50 minutes. Hopefully you learned some stuff, and yeah, thanks for coming out.
Thank you very much for the presentation.